G'day guys, it's Calvin from the Cartoon Company down under in New Zealand. Today we're going to look at the start circuit on a 1uz. The neutral switch and the STA input. And we'll sort a bit of stuff out because there's a bit of confusion around this. There's a few tricks. So we're going to imagine we're working on a car. We've got the car and we've wired it, and one of the questions people have is, will the engine crank over without the computer attached? So let's unplug the ECU. The ECU is not attached, and it's wired like a factory vehicle. So let's trace the start circuit. And it's just the same when it's in a car. We have the key. This is my key. And it goes on here to the start input. It goes here. It heads along and it comes to this plug here. There it is there. Okay. And it does head to the ECU. Let's go to this one here. There it is there. But that's only a signal to the ECU. It doesn't actually control the starter motor. Comes over to here. Hope I've got the right one, eh? Ah, it's the other one. There it is. So it comes down to the start inhibit switch, or the shift inhibit switch, or whatever you want to call it. I'm going to put it into park or neutral. So the contacts are now connected. I'm removing the start relay. So it's coming back up to this plug here. Again, this is wired like factory. Give me a moment. It's down here. It's this one. It's this one here. So it comes back to this plug. And guess what? It does send a signal to the ECU. That'll be this one here. So the ECU's got two signals. That one there and that one there. One is STA and one is NSW. Then goes from there to the start relay. And this is on an early one, Gen 1, Gen 2. There we go. VVTI, early VVTI is the same. Back to the start relay. And now, so without the ECU plugged in, the engine will still crank, just like in a factory car. So if your engine isn't cranking over, it's not your engine ECU. Simple. But there's some other little tricks when you're doing conversions that happen. My multimeter is about to turn off and I need it. The ECU is plugged in and powered up. Let's remove this relay here. And actually, I'm going to put this into my my fuel pump output, which is over here. Watch what happens when I remove my start relay. let's just see if I can remove the start relay. It's quite firm, which is probably good, really. We don't want it falling out. Ready? Our fuel pump's going. So I removed the start relay, and for some reason, the fuel pump's going. And what you can hear there is the fuel pump relay switching on and off. Now, why is this? Grabbing my multimeter, and we're going to put this in earth right there. We're going to go into NSW, neutral switch. Come on, give me some voltage. And that is reading 0.4 of a volt. 0.423 of a volt. Nine volts. 0.4, 9 volts. There is 9 volts coming out of that pin on the ECU. Now I've got the scan tool. I'm in the neutral switch wire, and this is telling me that the starter signal is off and the park neutral switch is on. However, I unplug this, starter switch is off, park neutral switch is in drive, and there's 12 volts from the wire, the neutral switch on the ECU. I don't have any feedbacks. I don't have any other wires connected to that neutral switch. It goes from the ECU down to the shift inhibit switch, and then out past the fuse to my ignition switch. Okay, it doesn't go anywhere else. The ECU is actually outputting some voltage, 12 volts. If you read the pin voltage charts, you will find that the neutral switch does output 12 volts. Let's keep going here. So I'm putting it back into neutral. There we go. Park neutral switch is on. I take the starter relay out. The fuel pump comes on. I've got 9 volts out of the neutral switch, and it's in gear again, and the fuel pump is running. No voltage there. 12 volts there. 12 volts coming out of that ECU. Now, if I put a little bit of load onto my start input, like in the ignition switch, bam, look at that. Everything works like it should. It's not lighting up, but there's just a little bit of load. I think I can probably do it with, let's see if I can blow some stuff up, eh? We'll just provide an earth. So simply providing an earth or a track back through the ignition switch is enough to change the whole dynamic of what's happening here. Also, having a start relay with the resistor in it also does the job. Now this is why when I do a manual, I don't connect the neutral switch. Oh, I didn't do the 12 volts. Did I do the 12 volts to this? Yeah, I did. Let's just do some 12 volts when I crank it. Because everything's grounded nicely. And I crank it. And I'm measuring 8 volts at the neutral switch. And 8 volts at the start switch. So what did we learn from this? You don't need the ECU to have the engine turn over or crank over. And that the ECU outputs 12 volts on the neutral switch at under certain conditions. And what I've seen, a lot of guys, they look at the pinouts and they go, oh, neutral switch should have 12 volts when it cranks, and the start switch should have 12 volts when it cranks. They join them together and they run them to a start trigger. Some of them backfeed that 12 volts, which you won't test with a test light, but you'll test with a multimeter or a oscilloscope, and it puts 12 volts back into the start signal. And that does two things. Turns the fuel pump on at different times, because that's what the start does. And it locks the timing at 10 degrees. So when you crank these engines, the timing's locked at 10 degrees because there's 12 volts going up the start trigger into the ECU. Have you guys ever driven a car that's locked at 10 degrees? Yep, found it. Many years ago, I had it was either a Mazda, I think it was a Mazda or a Ford Ute come in, automatic, and it was gutless. And I put it on the dyno, and it made 60 kilowatts. 60 kilowatts. After much checking and looking over and investigating and understanding, I found it had 12 volts to the start at all times. Not enough to crank it, not going to the starter motor, but 12 volts to the ECU. And I researched and learnt more about that circuit. It's a really easy circuit. It's also a really easy circuit to get wrong. And sometimes to solve this problem, it's just a matter of putting a resistor relay, a resistor protected relay into the circuit. I know the guys that are doing the more technical stuff and are coming across these problems will appreciate this, because a mate of mine in the UK did actually contact me about this problem recently. My mind was a bit blank, but it's clearly obvious once you find it. And certainly worth checking. Multimeter, not a test light. Not like me. I normally use the test light for most things. You might find it with an LED actually. So I hope that was helpful. Apparently the saying goes, make hay while the sun shines. So I've got some hay to go pick up. It's a good way to end the day. So talk to you again soon. Catch you later.